The James Webb Space Telescope provides a remarkable view into the universe as it existed over 13 billion years ago, profoundly reshaping our understanding of the cosmos and our place within it. This telescope has uncovered new insights about distant planets, far-off galaxies, and other celestial phenomena, marking a revolutionary advancement in astronomy and serving as a powerful successor to the Hubble Space Telescope. But what makes the Webb telescope's images so extraordinary, defying previous expectations and theories? And what insights has Bill Nye shared about these discoveries? The development of this telescope was the culmination of years of dedicated effort by NASA scientists and engineers. It was successfully launched on December 25, 2021, and over the following months, its deployment proceeded without major issues. By late June 2022, researchers had already identified thousands of previously unknown galaxies, some older and more distant than any observed before. A few of these galaxies may have formed as early as 150 million years before the oldest galaxies detected by Hubble. Additionally, the telescope can gather sufficient light from exoplanets and stars to analyze their composition and movement through space. According to Bill Nye, this data is already providing detailed information about the atmospheric makeup of planets located light years away from Earth, offering clues about their potential to support life. One of the Hubble Space Telescope's most iconic images was the Pillars of Creation in the Eagle Nebula. While Hubble captured this structure in visible light, the processes occurring within it remained hidden. However, the Webb telescope's infrared imaging revealed numerous protostars clusters of dust and gas, each several times larger than our solar system, appearing as small red dots against the backdrop of the pillars. These are stars in their earliest stages of formation, not yet burning hydrogen. Bill Nye explains that as more material accumulates at the center of these protostars, their density increases until hydrogen fusion ignites, causing temperatures to soar to around 2 million degrees Celsius. The colors in the image represent different infrared wavelengths, most of which are invisible to the human eye. The blue portions are the only visible light, while the red hues highlight radiation emitted by the protostars at wavelengths 6 times longer than what our eyes can perceive. This image not only showcases the Webb telescope's infrared capabilities, but also illustrates how stars like our Sun form. The first exoplanets were discovered in the 1990s, and today more than 3,000 confirmed planets orbit distant stars. However, only a handful have been directly imaged, as most are too faint to observe clearly. The first direct image of an exoplanet was captured in September 2022, a planet initially identified in 2017 and named HIP 65426. The scientists used specialized instruments to block the light from its host star, along with 2 of Webb's cameras and a series of filters to observe it. This planet is particularly visible due to its extreme distance from its star. About 100 times farther than Earth is from the Sun, and its massive size, nearly 12 times that of Jupiter, the ghost galaxy, also known as Messier 74, is difficult to observe in visible light but becomes clearer when viewed through an infrared lens. While its spiral structure and radiating star formations are visible in optical images, Webb's latest photograph reveals intricate filaments of dust and gas glowing in electric blue. This new image highlights star-forming regions along the galaxy's arms, providing deeper insights into its composition. By combining Hubble and Webb's images, researchers from the European Space Agency, ESA, created a composite view as part of the FANGS project, an international effort to study 19 nearby galaxies in infrared. Webb's high-resolution imaging allows astronomers to pinpoint star-forming regions, measure star cluster ages and masses, and analyze interstellar dust particles. In July 2022, an image of the star Wolf-Rayet 140 revealed an unusual pattern of concentric, slightly square-shaped rings surrounding it. Unlike the diffraction spikes typically seen in telescope images, these rings are a distinct feature of Wolf-Rayet stars, massive, aging stars that have shed much of their hydrogen. The unique shape of these rings results from interactions between WR140 and a smaller companion star. The Webb telescope was designed to observe the most distant galaxies in the universe. And in mid-December 2022, researchers announced the detection of 4 of the oldest galaxies ever seen. These galaxies date back 13.4 billion years, existing when the universe was just 350 million years old, about 2% of its current age. The discovery was made as part of the JWST Advanced Deep Extragalactic Survey, JADES, which used near-infrared spectroscopy to measure the galaxy's redshift, a key indicator of their distance. The highest redshift recorded was 13.2, confirming these galaxies as some of the most distant ever observed. Meanwhile, the telescope has also studied WSP-39b, a Saturn-sized exoplanet orbiting a star in the constellation Virgo, located 700 light-years from Earth. This gas giant is 8 times closer to its star than Mercury is to the Sun, resulting in extreme heat. Webb's spectroscopic analysis detected sulfur dioxide, silicates, and carbon dioxide in its thick atmosphere, marking one of the most detailed examinations of an exoplanet's composition to date. Asterisk.